So again, when I mentioned this yesterday and presented this yesterday, I told you that my biggest fear and historically the biggest challenge by teaching this is people start to forget how to complete the square. If you had to remember one thing, remember how to complete the square to find your zeros. That's more important than converting to vertex form, because you can solve this anyway using axis of symmetry formula, right? As long as you can do both and remember completing the square the original way to find your x-intercepts, your zeros, then no problem. Feel free to keep doing this. But I don't want you to forget completing the square, because if you take a test, if any of you have to take a test, if you're going to go to Santa Fe High next year, I don't remember who else offers it, that does a test, but if you have to, they're probably not going to ask you to convert it to vertex form. They're going to ask you to complete the square, guaranteed. Absolutely, no question. Completing the square is a big thing. You will get lots of those kind of questions. You won't get any of these, unless it's an Algebra 2 thing, because like I said, this is Algebra 2, not Algebra 1. Okay? So just keep that in mind. But what we talked about yesterday was y is equal, the vertex form is y is equal to a x minus h squared plus k. All right, and we're trying to convert from standard form to that. Standard form, again, is y equals ax squared plus bx plus c. So we're trying to go from one to the other. Okay? So I gave you this. I gave you something like this. Something like that, right? And I said, okay, we are going to basically take this plus 4 and move it off to the side a little bit. And we're going to put these two things in parentheses, right? So we're going to rewrite it like this. Y is equal to parenthesis x squared plus 8x. But we are also going to make a perfect square in here, so I'm going to leave a space. I'm going to put plus space. And then now this little plus 4 that I had moved off to the side, I'm going to put after that parenthesis, plus 4. You all know how to do this. And then I added something here. Normally for completing the square, I add to this side and I go to the other side and add to this side. But I'm not doing that. I'm completing a square so that I can create a vertex form. So since I'm adding a number to this side, I'm going to subtract that number again from the same side. Okay? Okay. Okay, so half of 8 is 4, right? So half of 8 is positive 4. 4 squared is 16. I added 16 to this side. For this to stay y equals, to still be an equality, I have to subtract 16 from this side. Okay, so everybody knows how to do this. So now I can factor this. This is a perfect square, so I can factor it as y is equal to x plus 4, x plus this, or half of this, squared, and then I have minus 12, right? And so that is vertex form. And my vertex is the opposite of this, comma, exactly this. So it's negative 4, comma, negative 12. All right, so that's pretty easy. And everybody knows how to do this. Right? Fist to 5, just so I know. Okay, awesome. Okay. Fist? You gave me a fist?
Yeah.
Okay. Okay. All right. So there's one thing that I didn't teach you and tell you about. This is only for when a is equal to 1. Look at this. In this case, look, a is 1. A is equal to 1. Now, that is great. But now it's a little different. It's actually the same thing. It's just that you didn't realize what you were doing over here. Now we're going to do one where a is not equal to 1. Okay? So here we go. Let's try this. Y is equal to, say, 2x squared plus 8x let me think. Plus, I don't know, let's just say plus 10. That'll work. All right, and I'm asking you to convert it to the vertex form. So we're going to start it the same way. We are going to move this plus 10 off to the side. Okay? Now, we are going to do this though. Y is equal to, but notice, look at the vertex form. What's out in front of the parenthesis? What is A in this equation? 2. So I've got to put a 2 out here, and then I'm going to put these things inside. But it's got to be, I'm factoring it, right? I got to factor 2 out of all this. So 2 times what is 2x squared? X squared, right? And then plus 2 times what is 8x? 4x. All right, 4x. I need more space. All right, and now I'm going to put plus space, parenthesis. Now I'm going to put this plus 10 here, and then I'm going to put a minus box. Okay? Just trust me for a second. Put it that way in your notes. The reason I'm putting space and box is because they're not going to be the same number. They are, but they don't look like the same number, but they will be the same number. And you'll see what I mean in a second. Let's complete this square now. What would we do to complete this, to find this thing? We would take half of 4, which is positive 2. Now we're going to square that, right? 4. Okay. Now, what would I put here?
8.
Why?
Because you have to double the 4.
Look, it says we're adding 4, but really, what are we adding? There's a 2 here. The 4 is inside the parentheses, and this has to be distributed to everything, the 2. So we're multiplying this 4 by this 2. So we actually are adding 8. We're adding 8 to this side, so we have to subtract 8. Right? That's why I'm suggesting put a line here and a box here. Whenever A is not equal to 1, when A does not equal 1, I suggest that. Okay? Does that make sense? So now, does everybody get that? Why I've got an 8 there? Okay. So now I go y is equal to 2, parenthesis. Now I factor this. What would be the factored form of that?
X plus 2 squared.
Right. X plus half of that, right? X plus 2 squared. And then I've got plus 2, right? And that's my vertex form. My vertex is negative 2, comma 2. Even when there's an A here in the vertex form, you still find the vertex the same way. No matter what A is, the vertex is always going to be the opposite of this number, comma exactly that number. Okay? Make sense? All right. So let's do a couple. Couple more. Questions? Did you have a question, Sina?
No, I thought you were going to raise this side up.
Okay. All right, so let's try y is equal to 4x squared minus 32x plus 40? Sure, whatever. Okay, so let's try that one. So I'm kind of converting it to vertex form. So it's going to be y is equal to, what's my A? 4. So I'm going to put a 4 parenthesis. What would I put here?
X squared.
X squared minus
8x.
8x, and then plus space, parenthesis, and then my plus 40. And I added to this side, I'm going to subtract from the same side, minus box. Because it's not going to look like the same number, even though it is the same number. Okay? So what would go here? Half of negative 8 is negative 4, right? negative 4 squared is positive 16, so you're going to put plus 16. Now, what are we going to put here?
4 times 16.
Right, what's 4 times 16? 4 times 6 is 24. 4 times
64.
64. So we actually added, even though it looks like we added 16, we really added 4 times 16, which is 64. So we have to subtract 64. Okay? So now I go in here. This is the easy part. I just do x minus 4. That's why I write the minus 4 in there. And squared. And then
Minus 24.
minus 24. So my vertex
4 minus 24.
is equal to 4 comma negative 24. And you guys all see why those are so easy to graph now when you have it in vertex form, right?
Yeah.
Piece of cake. Now, how would you graph this one? Just tell me. Somebody tell me.
Over 1 up 4 over 2 up.
Yeah, it's going to be because A is 4. It's not standard parabola guy. It's standard parabola guy times 4, right? So you're going to go over, once you go to your vertex, you go over 4 down negative 24, put a dot, and then you're going to go over 1 up 1 times 4. So over 2 from the vertex, over 2 up 4 times 4, which is 16, right? But it's a piece of cake. Really easy to do. I think that's it. So that's the end of this lecture, and I'm going to give you the homework you can get started. Some of you may finish